Okay, everyone, hello and welcome to Big MiniConf number 12. Yes. Okay, so we are going to present to you a bunch of tech talks in one day, and we are starting now at 1 o'clock. So just really quickly, while you're enjoying this stream, hello everyone out there in the audience. My name is Heather. In fact, not English Classroom 1, but Heather. Really nice to see all of you. Please follow us on social media for more information about our programs and what you're going to see today. So the talks that you're going to see today are the fruits of many, many weeks of hard work, in addition to going through a grueling 12-week bootcamp program. So we're really, really proud of our students and alumni who are presenting today, and we really hope that you enjoy the talks that you're about to see today as much as we have enjoyed preparing and rehearsing them for you. So here's the schedule today. Agnes, our events manager, is over there presenting on session B. So session A is going to look like this all day, and we will be presenting the schedule regularly throughout the day. So please do look back and reference this and head over and check things out that you're interested in. So up first is going to be Sivani, and she is going to be presenting Tailwind CSS, Falling in Love Again. So let's see. Sivani, are you ready to get started? Okay, so everyone, I'll turn it over to Sivani. Good job.
All right, let me just share my screen. Oh, I think I have to wait till you stop screen sharing. There we go. All right, I'm just gonna move my bar. Hopefully everyone can see and hear me okay. Let's get started. So hello everyone, my name is Sivani, and I'm gonna be talking about Tailwind CSS, Falling in Love Again. So first, let me take you through the agenda. I'm gonna start by introducing myself, talking about you and who this talk is for. Then we'll talk about my journey to discovering Tailwind. Do a little demo, go over the pros and cons. Give me 1 sec, let me get rid of the video. There you go. Then I'll go over resources, and that'll be that. So first, let's start with me. Hello, my name is Sivani. You can also call me Shiv. My pronouns are she, they, he. I come from a little beach town on the south side of India called Kerala, but I also have roots all around the world in India, the UK, the US, and now Japan. I'm a software engineer and an educator, and I have a background in game development, film production, and audio. And the common factor between all these things is I just like making cool stuff. That out of the way, let's talk about you. Who is this talk for? This talk is for beginners to web development, so as long as you have some basic working knowledge of HTML and CSS, this talk should be useful to you. It's also for skeptics of Tailwind, and for CSS veterans who are a little tired of maybe their development flow and are looking for something new. And I can relate to all of these groups. So let's talk about my journey. I first fell in love with front-end web dev when I was pretty young, actually, through Neopets. So if you're not familiar, Neopets is a virtual pet adoption site. And you can actually customize some of your pages there if you know HTML and CSS. That was my first introduction to CSS, and I loved it. Fast forward years later, I've now become a full stack developer, and my relationship to CSS has become more of a love-hate relationship. I love what CSS helps me achieve. I love working on design and visualization, but sometimes the process of using CSS can feel a little bit rough. So I was looking for a new solution to my problems and something to kind of make me fall in love with working with CSS again. And that's when I stumbled upon Tailwind CSS. So what is Tailwind? Tailwind is a CSS framework. It's a utility-first framework that uses utility classes. And if you don't know what that means, that's okay. We'll go over it in the demo. I also heard that was really good for customizing things and avoiding cookie cutter looking UI. I also heard it was very time-saving, and I knew that all the cool devs were using it, and it was really trendy, so I wanted to know what was up. So I decided to take a look and see what Tailwind looked like, and this is what I saw. If you haven't seen Tailwind before, I'll give you a moment to take this in. But as you can see, all the orange text there is Tailwind, and it is very horizontal. And when I first saw this, my reaction was, no, I don't want to use this. This looks bad. It looks messy. And I found out that this is a really common knee-jerk reaction that people have when they see Tailwind, because it looks like inline CSS. And we all have this sort of ingrained feeling, and for good reason, that inline CSS is bad. And inline CSS just means you're basically writing your CSS in your markup. But Tailwind is actually different from this and offers some unique benefits. I think the best way to show you that is to go over it in a demo. So let's do that. So over here, as you can see on my right, I have my local server running with some stuff that we'll go over in a sec. On the left, I have my IDE, and I am doing a Vue project, as you might be able to tell, because this file is a .vue file. Don't worry if you're not familiar with Vue. Everything we're going to be going over in this demo is going to be framework agnostic, and even if you don't use a framework, that'll be okay too. We're going to stick to working within this template area over here, and basically writing out our Tailwind utility classes in our HTML elements. So let's start from the top. First, we have main. So this is just going to be the landing page, or the little fox burrow, if you will, to house our little fox. Next, we have a div over here, which is going to be a card to contain a bunch of information inside. And the first piece of information we're going to use is this H1, Mr. Fox. So you can see that over here. Then we're going to have an image. I'm using Random Fox API, so shout out to them. I had a lot of trouble choosing between whether I should do cats or dogs for this demo. And I decided on foxes because it's the best of both worlds. And as you can see, we have our handsome fox over here on the right. And finally, we have our paragraph text. So that's at the very bottom here. What does the fox say? And if you watched as many YouTube videos of foxes as I have, you know, they make some pretty funny giggly sounds. All right, and that's it. So let's get started. We're gonna keep this demo really basic so I can take you through all the basic functionality of Tailwind and how it works. So I'm going to start up here on top with main, and I'm going to write a utility class that belongs to Tailwind. So I want to change the background color. So I'm going to say BG yellow, and let's stop here so we can take some stuff in. As you can see, I'm using a plugin for my IDE that is really helpful. It has autocomplete, and at the bottom, it also has the corresponding CSS for whatever Tailwind class that I'm using. Tailwind also has a built-in design system with constraints. So as you can see here, I have BG yellow 50 in gradations all the way to, whoopsies, all the way to 900. So Tailwind has built-in design constraints, which is really helpful because you won't spend too much time like picking exactly the right color, exactly the right number. But all of this is customizable, and I'll show you where to do that at the end. For the purposes of this demo, I'm going to stick mostly with defaults. So let's give this a nice dark brown background. Okay, so this is a Tailwind utility class, and I told you we were going to talk about what that means. So let's talk about it. A utility class means that the class is named for what it does and not for the visual element that it describes. So in this case, BG yellow 900 is just saying what it does to the main tag here. This is different from semantic naming of CSS that you might be more used to. For example, we might just say, hey, this is the landing page. And then I would apply a bunch of styles in a separate CSS file to this class. Tailwind is not like that. Tailwind, you just say what you're doing. So we have our first Tailwind class here. The next thing I want to do is add flex. And flex is something we have in CSS too. So if you have basic knowledge of CSS, Tailwind is pretty easy to pick up. Flex just means that everything inside this container will now grow and shrink based on the available space. So we're not going to see anything change yet. So let's make use of that. I want to horizontally align this. So I'm going to say justify center, and it jumps to the horizontal center. I also want to vertically align it. So I'm going to say item center, and we will not see anything happen yet. And that's okay. That's because we need to define the height of our screen. It doesn't know that yet. So if I do H screen, that's going to take up 100% of the visible viewport. And now we see it jump down. Fantastic. All right. Next, I want to move on to our div here. So now we're going to build out our card. I'm going to add BG yellow 500, give it a golden color. And then I'm going to make this a flex container as well. So I'm going to say flex. And as you can see, everything gets jumbled up, but not to worry. I'm going to add flex call. So this makes it flex along the column direction. And everything's going to stack on top of each other again. So as you can see here, this was partially because, of course, my IDE is really zoomed in for this presentation, and it's also only half the screen. But you might already be thinking, like, you can see stuff going off screen. It's getting really horizontal. And, that is something that is a feature of Tailwind. There are ways to overcome this. But, one benefit, too, is that when you look at the markup here, you can tell and easily visualize what an element's going to look like, even by just reading the code, which is nice. So depending on what your development style is, that might be a good or bad thing for you. All right, now I want to horizontally align that text too, but because we switched the flex direction, it's actually going to be item center for horizontal alignment. It jumped to the center. Yay. Next, I want to show you one of the key differences between Tailwind and inline CSS. And that is the fact that you can use pseudo classes in Tailwind, unlike inline CSS. A pseudo class is like state-based things, for example, hover. So if I say hover and I say BG yellow 400, now when I hover over this card here, it's actually going to get a little bit lighter. So it's that easy to add pseudo classes using Tailwind. And I just want to also point out, like here, a lot of the things we're doing, if I hover over, you see the corresponding CSS, and you can see we're saving a lot of lines of code. And I think a lot of this adds up over time. All right, before we leave this card alone, I also want to round out the edges. I should point out that Tailwind, this is also common syntax for Tailwind. You have like small, medium, large, XL, 2XL. I'm going to go with large rounded corners. Now the corners are rounded. Now I'm going to jump down to our image so we can work on that a little bit. So right now it takes up the whole width of the card, but I don't really like that. I want it to have a little space inside. So let's define the width. I can use W, and if I say 24, this is actually going to give it a width of 96 pixels. And okay, that's really small. I can also define it according to a fraction. So it's going to change depending on how much or how big the screen is. So now it's going to take 5 by 6 of this card. Okay, next, I want to add a border. So for border, you just say border and you add a thickness as a number. So if I say border 8, it's going to add a border all around. I can also target a specific side. So for example, if I do T, that's going to put it only on top. I can also do B for bottom, R for right, and L for left. But I think I like it being all the way around here. It's a default gray color, so let's change the color of the border too. I'm going to say border yellow, and let's say 700, so it's a soft brown. Nice. I can also change the style of the border. So if I wanted to do like a dotted border, for example, I could do that. That's pretty funky, but I think I liked it being a solid line, so let's keep it that way. Cool, and the last thing I want to do is round out these edges too, so it matches the outer card. Very nice. Now let's work on the text. So I'm going to jump back up here to our H1 and start adding utility classes here. First, Mr. Fox is a title, so I think it deserves to be bigger. Let's make it 2XL. And let's change the color of it as well. So I'm going to make it a dark brown instead of a stark black. Same as the background color. Okay, and I also want to change the font family. So I'm going to do font mono. It's going to use the default mono family that I have set. And I want to add a margin. So margins work similarly to border. It's also similar for padding in the sense that you can target a specific side. So if I just do M and a number, it'll target all over. I could do MT for top and so on. Also, if you want to target right and left, you can do X, or top and bottom, you can use Y. So I'm going to use MY2, and that's going to give us a margin on the top and bottom of this text. Okay, so now it has a little more breathing room. I think Mr. Fox deserves to have his name capitalized, so I'm going to add capitalize. Perfect. And we can also mess with the tracking, and I'll show you that. And what I want to point out here is One thing I really like about Tailwind is that the naming of the utility class is also often very human and intuitive. So I'm going to say I want tracking widest, which means I want the space between each letter to be pretty wide. So as you can see, now we have a little more space between each letter. Awesome. I want to do something similar to our paragraph text. So I'm going to copy these over and paste them into the p tag. Save, and let's mess around with this a little more. So this shouldn't be too big because it's not a title. So I'm going to change it to MD for medium. And I think the color is okay, the font's okay, margin's okay. Instead of capitalizing the text, oops, sorry about that. I think I should italicize it because it's a quote. I'm going to say italic. Cool. And the last thing, just to show you something different, let's try changing the leading or the line height. And I'm going to say loose. And now we have more space between each line. Yay. So we have a nice little home for Mr. Fox now. One last thing that I want to show you, or two more things really. First, I want to show you how you can customize the defaults. So I've been using lots of defaults here, right? Like BG Yellow 900. What if I want to use my own colors? Don't worry, you can do that very easily. So if you create a tailwind.config.js file in this case, because this is using JavaScript, you can either change the defaults or add on your own. So in this case, I've actually added an extra color here called Foxy Brown. That's a more dark reddish brown. And it's really easy to customize anything else too, like border radius, padding, margin, screen size, etc. So let's try that out. And I want to try it out because I want to show you something else, which is the other major difference between inline CSS and Tailwind is that in Tailwind, there are you can use media queries right in the markup. So media queries means basically making your stuff responsive based on the screen size using breakpoints. So if I write SM like I have here, this is the small breakpoint, and this is actually for, so you can see this is for a 640 pixel screen. So something slightly bigger than a phone, maybe a small tablet. When I hit that breakpoint, let's say, let's change the background color to my custom color, Foxy Brown. So I'm going to save. And as you can see, it got a little more dark and reddish. So if I go small again, it's going to go back to the old color. And when I hit that breakpoint, it's going to go to the darker color. So it's that easy to make your design responsive. Cool. Before we move on, I just want to point out a few little things. So for example, with the text here, you might have noticed with the H1 and the P tags, there is some repetition, right? So like the text color, the font family, the margin, they do repeat. And if you start to see a large repeating pattern in Tailwind, you don't have to worry. There is a way to deal with that. You can extract those into a common class, similarly to how you would do with normal CSS, using something called apply. You can also, of course, if you're using a framework like Vue or React, extract things into components as well. But I won't be going into that for this demo, but just pointing out that there are ways to handle that. Okay, let's go back to the slides so I can show, so we can go over pros and cons. So hopefully you could see from my demo some of the pros. One thing that I really like about Tailwind is really time saving. One, because if you already know CSS, Tailwind is really easy to pick up. And also, if you're not that familiar with CSS, I think it can actually help you become more comfortable with CSS. Two, I think it's time saving because you don't have to keep switching between different files because everything's in the same, it's all in your markup. Three, I really like that Tailwind has design constraints because it saves you a lot of time between trying to pick a specific value all the time, and it kind of forces you into creating your own design system too, which is great. And lastly, and very importantly, because Tailwind, you don't have to worry about semantically naming your classes or coming up with your own class names at all. It saves a lot of time. You just use the utility classes provided. Another thing I love about Tailwind is it's really easy to customize things from the ground up, and it feels really intuitive to me. It's like putting together blocks. It's also really great for scalability, and this is really hard to show you in such a small demo, but as you can imagine, you do end up saving a lot of space on all the CSS files you're not making if you use Tailwind, and there are case studies that show this. Also, because Tailwind uses something called purge CSS under the hood, any classes that you don't use are actually removed, and don't take up space. For example, if you never use BG Blue 400, it will not take up space in your application because it will be removed. And finally, this is debatable, but depending on how you feel, some people like that with Tailwind, when you read through your markup, you can very easily visualize what each element looks like because of how readable the utility classes are. Of course, there are cons. So if you are a designer or someone with a plan in mind, Tailwind feels great to use. But if you're a backend developer or someone who just wants to quickly slap together a prototype, and you kind of just want things to look good and standard, and you don't want to customize things too much, Tailwind might actually feel like it's overkill for you and maybe even more time consuming. However, there are Tailwind UI component libraries that can help you overcome this issue. I think the main con, though, is that no matter how much you might try to look past it, for some people, Tailwind just looks kind of goofy. It looks like too much going on, and that's a totally valid opinion to have. So given all that, why would you choose Tailwind for your next project? Let's try comparing some extremes. So on one side of the stage, we have vanilla CSS. And vanilla CSS is great because you can get into the nitty-gritty of things and have 100% control. You're in the nuts and bolts, but that also means that you have the responsibility and the complexity that comes with that. On the other side of the stage, you have something like Bootstrap, which is a much more high-level framework. And so it gives you components that you can work with, and they look good, they look standard and they look good, but it's harder if you want to override and customize things and can actually take more time in those scenarios. And then you have something like Tailwind that's kind of in between. So it's pretty low level. It's close to CSS. So you do have more control than something like Bootstrap or frameworks like it. But you're a little bit cushioned from the complexities and some of the frustrations that you can encounter if you were working with CSS directly. So I put Tailwind somewhere in the middle, maybe a little bit closer to CSS because it is a pretty low-level framework. Bootstrap's on the higher level side, and there are lots of frameworks that fall between Bootstrap and Tailwind. But I like Tailwind because it feels like it's as low as I can go while still having something more intuitive to use than CSS itself. So it's really very personal, and it's all about your development process. And for me, falling in love with Tailwind was all about falling in love with the process of working with CSS again and rediscovering the joy I had working with CSS as a child. So as someone who also felt skeptical when I first saw Tailwind, the final thought I want to leave you with is, what about your current process of working with CSS gives you the warm fuzzies? And what about the tools you use right now make you excited to work on your front end? And I ask this because a lot of people have a knee-jerk reaction to Tailwind and they don't want to try it. But I think if you looked at Tailwind and you decided it wasn't for you, you should at least give it a go. And that's because the critical knowledge and insight that you can gain from trying a tool that's really different from what you're used to, that critical insight is invaluable. And the final thing I want to leave you with is some resources. So Tailwind has great resources available. The documentation, which is the first link up there, is really great. And what I like about it is that it also offers a lot of the philosophy behind why Tailwind works the way it does. There are also UI component libraries. Tailwindui.com is actually paid and it's official, created by the creators of Tailwind, which is nice. But if you're looking for something a little cheaper, tailwindcomponents.com is one example of an open source free library of Tailwind components. There's also Tailwind IDE plugins available, like the one that you saw me using today with VS Code. That was super helpful. And there's a lot of tutorials, shouting out Adam Wathan's tutorials in particular, because it's nice. Adam Wathan is a co-creator of Tailwind, so seeing him talk you through the process is really interesting and helpful. And that's it. So thank you so much for listening. My name is Sivani, and my handle on most socials is Hey Sivani. If you're interested, you can check out my GitHub, and I have this repo pinned if you want to look at the code. Thanks, and see you out there.
Okay, thank you very much, Sivani. That was an amazing talk, and I'm sure that all of us feel overwhelmed by how cute Mr. Fox was. So thank you again, and congratulations on all of your amazing hard work to have completed that talk. So at 1:30, we are going to have Yoko Tsuda. She is going to be introducing Git and GitHub to us, so very, very useful knowledge. So be sure to join us back here on track A at 1:30 for Yoko's introduction to Git and GitHub. And so I'm just going to leave the schedule up here so everyone can see them while they're waiting. See you at 1:30. Okay, everyone, welcome back. It is now 1:30, and we are excited to present Yoko, who is going to be giving us an introduction to Git and GitHub. So Yoko, are you ready? If you're ready, go ahead and turn your video on. Okay, awesome. Let's give it up for Yoko.
Okay, hello everyone. And today I would like to be introducing you guys to Git and GitHub. This presentation's flow will start from an introduction to myself and why I chose this topic. And then a rough explanation of the relationship between Git and GitHub. And then finally, a quick walkthrough of what you can do with those two technologies. Now, you might have noticed that I keep using the words like a rough explanation or a quick walkthrough. And this is because there's a whole ocean of facts and features about Git and GitHub, which goes down very deep. And I'll only be talking about the very surface of these two technologies today. So, first, a little about myself. My name is Yoko Tsuda, and I'm Japanese. And I have an experience of living in the United States for 5 years during elementary school. I like solving puzzles and riddles and traveling abroad. And I am now a student at the Code Chrysalis Bootcamp. So why did I choose this topic? When I entered Code Chrysalis, I was introduced to Git and GitHub for the first time in my life. And I had never seen or heard of it before. And I was always having questions like, what is remote? Or why do I need to push or pull or commit? Or just generally, what just happened when I do this? And it took me a while to get hold of what was happening under the hood. But when I did understand, I found out that it was not as scary or complicated as it felt at first. And having the general image of the flow helped a lot when discovering new Git commands. And so I could easily imagine and understand what was happening. And I thought it would be nicer if all of the Git and GitHub beginners had that understanding as well. So on to the real topic. In the shortest sentence possible, Git is a version control system, and GitHub is a platform for hosting and collaborating on GitHub repositories. I know you guys get this a lot, but what, right? So let's go into a little more detail. So like I said, Git is a version control system. Let's say I wanted to draw a picture of a cat. In real life, this would be my code or an application for something, and drawing would instead be coding, but let's keep it simple for today. So first, I would draw the head, and using the feature of Git, I can keep a memo of what I did and how my drawing looked like when I took that memo. So after I draw the head, I can create a memo using Git that says drew head, and so forth. After I draw the ears, I would say added ears, drew face, and maybe made the ears a little bigger. So this set of drawings, or in real life codes, is called a repository, or repo for short. And so this repository would be like a book with all the changes listed and saved in it. And when Git is a book, GitHub is like a bookshelf with a lot of books on it, or more like a library. It is a website with countless repositories from people all over the world, and you can see or copy them and also contribute to them. This means that it makes contribute to them, and means that it makes your life easier when you want to work on a project with another person. You don't have to send emails with data to everyone. So how does this work? Let's get into a little more detail about Git and GitHub and what they can do and how it works. in real life, your repository can look like this, or this, or this. This last one being the repository on GitHub. It's basically a folder with files that have all the code of your application in it. But again, for the sake of simplicity, I'm going to stick to my cat drawing analogy. So I have my repository or repo on GitHub now. One day, my friend Becky, she sees my cat repo and thinks, hey, this looks really nice. I want to work on that project with her. Or maybe just, I can make it look way better than that. So anyway, to pick up where I left off, Becky can copy my repo and make her own repo on GitHub. This is called forking. So Becky just forked my repo, and it's done using a GitHub feature. Then Becky would take that data from GitHub and download it to her local computer so she can work on it there, like so. This is called making a clone or cloning, and this is done using a Git feature. Now, I want you guys to be aware of the relationship that is made here. This repo is a clone of Becky's repo on GitHub. And this repo is the remote of this repo. And since Becky's repo over here was forked from Yoko's repo is called the upstream of Becky's repos. But the color is faint here now because it's not really connected by Git yet. We just call it the upstream. And also these relationships are relative. For example, if someone from someone else's repo, like maybe George or somebody, these repos would not be the upstream or the remote of that repo. So next, now that Becky has all the data of my cat on her computer, she wants to make it, she wants to work on it and make it better. So like what I did earlier, she can make changes like adding a ribbon and making notes of it using Git. This is called staging and making a commit. Oh, sorry. So she can also commit a group of actions. So making a memo of every whisker that she draws, like whisker 1 and drew whisker 1, whisker 2, drew whisker 2, that would be too troublesome. And yeah, she doesn't really want to do it for every whiskers. So instead, Becky can commit after she has drawn all the whiskers and make a memo added whiskers. Okay, so now Becky is somewhat satisfied with her work. Her goal is to combine the new feature of that cat with my repo that I've made on GitHub. Sorry. Yeah, she wants to combine it with my repo on GitHub, but sorry. So first, she has to put that data to her computer, on her computer to her GitHub repository. Or to phrase it more professionally, she needs to push that data to her remote repository on GitHub, like so. So now that Becky's repository on GitHub is looking good, but mine is still looking like this. She wants to contact me and say, hey, sorry. She wants to contact me and say, hey, I've made this new feature on your cat, and do you want to combine mine with yours? This action is called making a pull request, and it can be done on GitHub. Then when I get that request, I can decide if I want that new feature or not. If I don't like the ribbons or whiskers, I can decline the request and my repo would stay like this. But if I do like it, I can merge Becky's repo and I can merge it to my repo. So I would have a cuter cat. Now, time has passed like 3 months and I've made some new updates on my cat. It has now a red ribbon and a body. Then Becky comes along again and she thinks, I want to work on that or I can make it better again. But the repo on her computer looks like this. And she wants to work on where I left off with the red ribbon and body. So she can do the same thing like she did before to fork my repo and clone it to her computer and work on it there. But then she would still have that repo with the older version as well, which means 2 repositories on GitHub and on her PC. And it would just be a waste of time and memory space. She can do something else instead. Right now, Becky's repos look like this. And if you remember from when we forked and cloned earlier, these 3 repos had a relationship between them. So this is the remote of Becky's repo on her computer. And they can pass data to each other. But although this Yoko's repo is called the upstream of this repo, Git doesn't really know about that yet. So Becky can't fetch or pull from this repo yet. So now Becky wants to add a relationship between these 2 using the command add remote. And to tell these 2 relationships apart, because they're both remote now, Becky can name the new one upstream, because Yoko's repo is the upstream. It's called the upstream of Becky's repo on her computer. And because now they have a relationship, Becky can fetch data from my repository on GitHub onto her computer and merge that to her repository. These 2 processes, fetching data from a repository and merging it, are often put together in one command called pulling. So Becky pulled from my repository. And now she can work on it there, commit the changes, push to her remote repository on GitHub, and make another pull request so I can merge it to my repo, and so on. Okay, so now time has passed yet again, but this time Becky and I were both busy and didn't have time to update the cat. But another person, Joe, comes along and he forks my repo, clones it on his local computer, made some commits, and then pushed to his GitHub repo this new cute feature. And now Becky, she has time now. She wants to work on where Joe left off. But how to get that data from Joe's repository? Although it's not the original remote of Becky's local repo, nor the upstream of Becky's repo, Becky can again use the git command add remote and maybe name it Joe and add that relationship between them as well. Now Joe's repo is also a remote of Becky's repo, and Becky can pull from Joe's GitHub repository. and work on it on her computer. Okay, that will be all for the details of what we will go through today. And for a quick review of what we've gone through, I made the simple web app so you guys could click through step by step. So let's have a look. So first, there's my repo here, and Becky's repository and on GitHub and PC is not there yet. So first, when I fork Becky's repos, looks like this now, and I can, Becky has cloned it on her computer and added the features on it. Oh, it's not coming. I'll fix that later. And push it. Oh, I'm sorry, it doesn't seem to be working right now. I think it's the Heroku site that I had deployed on, but I will fix on that after this presentation, so please take a look at it. So back to the presentation. So as I've said in the beginning, I've only scratched the surface of both Git and GitHub today, just the big picture. So if it seemed interesting to you and you want to know more about it, or maybe you have to know about it for your job or something, I'd like to introduce you to this website where you can practice and visualize Git commands on it. And it looks like this. Just a quick introduction. There are information, and you can practice different levels of Git commands. The first one is Git committing. So it has explanation, and it shows you this. Today I use the cat analogy, but most of the time, this kind of graph is used to visualize Git's flow of version control. And when I press Git commit, the graph actually moves and illustrates what just happened right now. So this is the goal. And okay. And it shows you the goal again for this level. And this is like your virtual terminal. And when I do Git commit, it again moves and shows you what you've done on this graph. And it really gets complicated in the end, but it's great when you can visualize it. And there's always some more tutorials on YouTube, but I'd like you, you can always read the documentations of Git and GitHub repositories, Git and GitHub sites, which might sound like tons of reading and really time consuming, but Git actually has some good video tutorials in there as well. So I recommend taking a peek in there before you go to the YouTube. That will be all for my presentation. One fun fact that I want to add is the cat drawing was used only was drawn only using the shape of Google Slides. I'm no artist, but I did pretty good, don't you think? Anyway, below is my GitHub and Twitter handle if you ever want to contact me, or either English or Japanese would be fine. And the URL and also the QR code leads to that site I made and tried to use on the review slide. Thank you all for listening.
Hey, Yoko, thank you very much. And I'm seeing a theme developing on this track today with cute foxes and cute cats. So thank you very much for that introduction. Up next, we are going to have Mai Asaomi, and she is going to be also doing an intro talk to generative art with p5.js. So please join us back here at 2 o'clock for Mai's talk. See you then, everyone. Okay, welcome back to Big MiniConf Track A, everyone. Hope you had a nice break. So up next we have Mai, and she is going to be presenting an intro to generative art with p5.js. And so Mai, are you all ready to go? Okay, everyone, let's give it up for Mai.
Okay, thank you, Heather. I'm gonna share the screen. Okay, hello. Thank you for coming. I am Mai. Today, I'd like to talk about making art with programming. As you can see in the title slide, I will use p5.js to create generative art. I think even beginners to programming will enjoy this. So let's get started. Today's contents table. I'm going to talk about generative art, p5.js, which is main topic today. Also do demo of art made by programming, live coding, and talk about the challenges I faced. First of all, let me introduce myself. I used to teach Japanese in Australia, and now I teach English to children in Japan. I enjoy singing and doing yoga as hobbies. Also, I'm about to start playing guitar, influenced by my friends and instructors at Code Chrysalis. One of my motivations for walking is to buy good treats for my cute dog named Ichika. Encounter with programming. A while ago, I became friends with the graduate student Asami. She is in the pictures with me. She was studying hard to become an engineer, software engineer. And at that time, I had an image that most engineers were men. So she looked so cool, especially when she was happily talking about technologies. Then I suddenly started studying programming. Studying programming was tough at first, but little by little, it became more fun. I am now excited to learn new technologies and make something fun with programming. Then I thought it would be wonderful if I could connect programming with what I like to do. I came up with an idea of creating art with programming because I like art. There are many kinds of art, but when I looked up what kind of art can be created with programming, I found something called generative art. What is generative art? Generative art refers to artworks that are algorithmically generated, synthesized, and constructed by computer software. It is a work of art that is drawn on a computer, but since it is a work of art that is created by considering mathematical algorithms and deliberately incorporating chance, it seems impossible to imagine the finished product. That's what I find interesting about it. Let's look at some examples. It is a generative art that reminds me of the famous painting, The Scream. It is drawn using a computer and pen plotters. The colors and curves are so beautiful. This is another unique and interesting piece. The red color seems to be dancing. It must take a lot of sense and time to paint this with human hands, but with a computer, it can be made in a short time. This is a very mysterious art. It has a computer-generated feel to it. It gives the impression that it is drawn by a complex algorithm a little bit. So, generative art.
I was inspired by these fresh and unique arts that I wanted to make it myself. Since I've been learning JavaScript for a while, I decided to look for a JavaScript library that would help me create this art. Then I found p5.js. According to the official website, p5.js is a JS client-side library for creating graphic and interactive experiences based on the core principles of processing. It seems that p5.js can be used to do some creative things. Since it is like a JavaScript version library of processing, let's take a look at processing as well. Processing is a programming language that and integrated development environment, IDE, for electronic art and visual design. It is based on Java and provides a wide variety of methods for writing graphics, making it relatively easy to enjoy visual programming. It is confusing for beginners to programming, but Java and JavaScript are completely different languages. I remember buying a Java textbook, even though I wanted to study JavaScript. Anyway, processing uses Java, while p5.js is based on JavaScript to write code. There are also various libraries available in p5.js. For example, p5.dom allows you to interact with HTML5 objects such as video, audio, web camera, input, and text across the canvas. p5.sound extends p5's web audio capabilities to include audio input, playback, analysis, and synthesis. p5.accessibility makes the p5 canvas more accessible to the blind people and visually impaired. You can also use other useful libraries. So apparently, p5.js can be used to create generative art. Let's give it a try. Let me show you an art first. I named it Colorful Circles. As you can see, it is an art of colorful and variously sized circles, and it gives a fun and a bright impression. Is it hard to make it? No. This looks fancy, but it was created with just 8 lines of code. I will be live coding for this, so let's create it together. Okay. If you want to use p5.js to create serious art, as for the knowledge required, it would be good to know how to write JavaScript to some extent. Also, there is an easy to understand development environment called p5 editor, but this time I will write code using the text editor, VS Code, and use Google Chrome browser. Okay, so let's do it. I'm gonna erase this. Then save. Now you can't see anything now. Okay. So, when writing code in p5.js, it is important to remember the setup function and the draw function. The setup function executes the process only once at the start. This is the initial setup. After that, in the draw function, the process is executed repeatedly. This is an actual description. the art we are trying now can be created using only the setup function. So let's write a setup function. Set function setup. Okay, step 1. Oh, by the way, there are 5 steps here. Now we are trying step 1. Step 1 done. Okay, so step 2, create canvas. In the function, we first need to create canvas. We want a full screen size canvas, so we will use the variables window width and window height as parameters. So let's do that. Create canvas, and as parameters, I will write window width and window height. Create canvas, window width, window height. Great. So step 2 done. Now we are ready to make an art on canvas. Step 3, create 500 circles with for loop. We want lots of circles for next step. How can we create them? Yes, for loop. Let's create 500 circles here. So I'm gonna write for statement here. 0, I equal less than 500 because we want 500 circles. Then I plus and open a curly brackets. Okay, great. So step 3 done. Step 4, set up the color using fill function. It's good time to learn fill function now. By using it, you can set the colors to be used for filling in the shape. For the first parameter, enter red or the hue value for the current color range. For the second parameter, enter green or the hue value for the current color range. For the third, same thing, but for blue. The fourth parameter is alpha, which is the transparency value. By putting them into the random function, we can represent random colors. For example, writing 250 will give you a random value between 0 and 250. So let's write a fill function. Fill, fill. Okay, so first parameter, I need the red. In the random function, maybe 250. Then for second parameter is for green. Okay, 250. I want a various color. So for the third parameter, I need for blue. And the fourth parameter for alpha, transparency. This can be same, maybe, yeah. Okay, seems good for me. Excellent. So step 4, done. Okay, the color is ready now. Step 5, draw actual circles with color using ellipse function. As you can guess, the ellipse function allows us to draw an ellipse to the screen. The ellipse function takes 4 parameters. The first parameter is the x-coordinate of the center of the ellipse. The second is the y-coordinate of the center of the ellipse. And the third is the width of the ellipse. Fourth is the height. If we don't write the fourth parameter, the third parameter will be used for width and height. So we can draw a perfect circle. This time, let's put window width, window height, and 100 into the random function. And yes, ellipse function. So let's write it here. Ellipse. Ooh. Okay. Then the first parameter should be window width, right? Window. Oh, but in a random function. Random window width. Okay, then random window height. Last, random 100, the size of the circles. Okay, I hope it works. Now we are ready to go. So we're going to save it. Okay, let's look at our art in a browser, please. Yes. Okay, we can see a lot of circles and it's getting closer. But maybe we don't need counter line of the circles. Okay, so let's get rid of them by adding no stroke function and have a look at it again. Okay, so here you write no stroke, then save it, check it again. Yes, very good. Counter line disappeared. Nice. Yeah, this is the art. This is the art I created. And if you want blue and green based circles, you're gonna change the number of the first parameter of fill function. This is for red, so change it 0, and save it. Now we can see blue and green circles, but no red circles anymore. Excellent. And going back to the code, if you want to reduce the number of circles, how can we do that? We can reduce the number of loops. Okay, so if you want 100 circles, save it. Okay, now we can see maybe 100 circles on our screen. This is how we create one of the generative art. Okay, so going back to the slide. Next, let's take a look at a slightly more complicated piece of code using both setup function and draw function. Look at the art of the falling cherry blossoms. Oh, this is beautiful, isn't it? The spring is coming, so I thought it's nice. And can you see my mask? I hope you can see it. My mask, the sakura is printed on my mask. This is mask for today's presentation. Okay, so let's have a look of my code quickly. Yeah, this is my code for the sakura art. And in the setup function here, yes, I created a canvas just like in a colorful circles, but the main difference between this and colorful circles is that I created a class for cherry blossom petals here. I initialized the coordinates, set up the petals to fall at different sizes and speeds, and made it possible to delete the petals after the end of the screen. Okay, in the draw function here, okay, I used the class to create a random number of cherry blossom petals for each frame and loop them. So in line, which is used by everyone for texting in Japan, snow falls on the screen during the Christmas season, and cherry blossoms fall in spring. It made me happy to know that I could do something similar with P5.js. Okay, so let me talk about challenges I faced. Sometimes I had to learn math, like x coordinates, y coordinates, sine, cosine, etc. It was a little hard to understand, but I found it was essential when we want to create variety kind of generative art. If we want to make complex art or add movement to our art, we have to use a lot of functions. It takes time to understand different functions and parameters, but I want to actively learn so that I can make great creative art. How I can actually connect the art I created here to the website and UI is what I will be working on in the near future. I would be happy if generative art could be useful in many places. So with P5.js, you can enjoy programming as if you were playing. Also, you can create infinite art and you can make your UI gorgeous. In my case also, I really enjoyed the programming when I touched P5.js. If you are interested, give it a try and create your art. Thank you for listening. This is my Twitter account and a GitHub handle. Thank you.
Okay, thank you very much, Mai, for that lovely talk. Indeed, your mask looks very nice with the piece of generative art that you created for your program. So awesome, awesome work. Up next, we have Seth Wright, and he is also going to be doing an intro talk. So he's going to be teaching us about effective UX design, and that's going to start at 2:30. So see you back then, everyone. Okay, everyone, welcome back to Big MiniConf. So up next to conclude our talks for the early afternoon before intermission, we have Seth Wright, and he's going to be introducing us to effective UX design. So Seth, are you ready?
I think so.
Okay, great. Take it away.
Let's see. Can you see my screen?
Yep, you're good.
All right, great. Okay, all right. Hello, everybody. I'm Seth. Today, I'll be talking about effective user experience design. And more specifically, I want to cover some of the best practices for today and what the best implementations are. Okay. Right. But first up, I'm just going to tell you a little bit about me. I'm a student here at Code Chrysalis. I lived in Tokyo for about 8 years now, and but originally I'm from this city here in the US called Salt Lake City. I have a pretty diverse working background, from IT intern to web designer to genetics lab assistant. Then since coming to Japan, I've been an English teacher and I've even worked in HR. So quite diverse, and I love bicycling and hiking, and I'm basically a lifelong tech and design enthusiast. And after the presentation, I'm going to share my QR code with you with some contact information. So, all right. Right. So why is UX design important? Well, this is something that I've been interested in for several years. And when conceiving these talks, I immediately knew that this is the topic I wanted to discuss. But what makes it so important? Well, you know, UX is one of the biggest considerations when conceiving a new product or service. And it's really important, yet so easy to get wrong. You know, as users, if an experience is frustrating, we're likely to not want to repeat it. Just to give you a silly, trivial example, you know, one day I was trying to order food from a restaurant's online portal. This was probably my third go at trying to use this service. You know, I liked their food; it was good. So I wanted to keep giving it a shot, but each time I gave up because the experience was just really terrible. I didn't know if my order was being recorded. It wasn't clear if it was pickup or delivery. And I honestly, I didn't know sometimes if I was looking at the shopping cart or if I was still browsing the menu. Um, so, you know, this time I thought I'd finally figured it out. And then after about 30 minutes, I clicked order and it errored out and said, you know, the restaurant was already closed. So, you know, what a waste of time, right? And I'm sure, you know, many of you have had terrible experiences like this using websites in the past. So this has a huge effect on businesses, and companies can spend a lot on advertising and yet still get this core experience very wrong. User experience is, you know, really bad. Sometimes when it's really bad, users will actively avoid a business that they would otherwise like and instead go to their competitors. So is this really urgent? Well, if you read the news a lot, you're definitely going to see a clear trend on where things are going. And I don't need to tell you that it was obviously accelerated last year. Even Disney, the largest media company in the world, which had already launched a Netflix competitor last year, surprised with a reorganization in October to restructure their whole company to prioritize online streaming, because things were shifting much more quickly than they even anticipated. So, you know, every year it's getting increasingly important that we get these digital experiences right, because more and more economic activity and consumption involves digital touchpoints. So now that we know it's important, what is user experience exactly? It's important to be specific. Um, well, user experience is often confused with user interface, and some companies will even hire user experience designers and UI designers as the same person. And that's because sometimes there can be overlap, but you know, and some professionals, they'll say, oh, UX and UI, there's overlap, or, you know, UI is a subset of UX. Or some will say they're absolutely different. The difference is not so important that we have to be dogmatic about that exact conceptual relationship, but it is important to remember that these are trying to accomplish different tasks. So UX design and UI design require different skills, and it requires a different process. So UI is about interaction, the menus and the buttons. It's about the presentation of the app, the visual creative direction. It's what's tangible. But the information conveyed on a page, on a list, or in a checkout, for example, that's the user experience. So user experience is a journey. It's the steps of using a product or consuming a product. Do I sign in before I access content? What are the steps I need to take to use this service? What information do I have to provide? So UI and UX are both important and they're complementary, but UX is more about stepping back and looking at the big picture. It's about the task flow, the information flow, and it's about user behavior. A simple example of UX versus UI would be the interior of a car. So you have the steering wheel and you have the console. That's the user interface. But the order of tasks accomplished, turning on the car, driving the car, that's the user experience. So next, I'm going to talk to you about the history of UX a little bit. And as you can see from the last example, it's not just digital. In fact, even though UX as an industry is something that's been formalized only recently, it's been around for perhaps as long as humans have made things. So feng shui, the Chinese philosophy, is thousands of years old, and it's concerned with optimizing the efficiency of movement by spatial organization of objects. Another example, Toyota in the 1940s, they formalized the gathering of user input by using their own employees for user research. And this is considered an innovation today in UX design. And changes in technology change what's possible in a user experience. So we should constantly be asking ourselves how an experience can be better or feel more common sense. All right, so now that we have some historical context and we know what user experience is, we know that context and technology of our era is important in designing a user experience. So I want to share with you some philosophies for successful user experience design for today. And I'm going to go over this pretty quickly, but we're then going to loop back with some real world examples just to illustrate a few of them. So first off, user experience is for a specific user to accomplish a specific task. And this is somewhat of a twist on a classic UX design paradigm that user experience should adapt to a user. But I'm refocusing this point here on the interplay between user and task, because task is the whole purpose of a user experience. It's like when you call 911 or 110번, the process is designed for a user, around a user, but also the urgency of the task, which is getting help. So when making user experiences, we need to consider the user, the context, and the aim of the task. Next is abstraction of complexity. This is so important, and this is something that many companies, especially in Japan, tend to struggle with. It builds on the previous slide a bit, but as developers, we need to strive to reduce complexity of achieving a user's goals. And constantly asking ourselves, how can we remove steps that might be burdening the user? For example, if you've ever started mobile service in Japan, you may have spent 2 hours filling the same information repeatedly into dozens of different documents. It's usually a pretty horrible experience. But finally, in the last couple of years, there's been more competition in this space, and the process is being streamlined. Rakuten, for example, has a very simple and straightforward sign-up process for their mobile service. And speaking of phones, another example of abstraction of complexity is going from all of this here to this. This is kind of the ultimate example of abstraction of complexity and simplification. And as developers, we need to strive to replicate this degree of simplification, but do it on the small scale inside of our apps. And completeness and trustworthiness. We need to develop our apps in a way that's complete and trustworthy. We need to consider all of the usage scenarios and properly test our products. For example, recently I used a flea market app to sell an old laundry machine. And it turns out that this app allows you to sell a laundry machine, but it doesn't support any shipping services that will ship a laundry machine. I mean, that's crazy. It's a completely incomplete experience. And I feel like I can't trust or rely on this company anymore. So, if we confuse users, the cost both to the user's time and the cost to a company add up quite a bit. And, incomplete user experiences can be the ultimate driver of customer support costs to a company. And pretty simple, but we should never bait and switch users by obscuring costs or obscuring how to do something. So we just need to always be upfront. And lastly, we need to be inclusive, meaning we need to design for a wide pool of users, different cultures, abled, disabled, etc. This isn't just morally better, but if you think about it, it's obviously better from a marketing perspective. And it needs to be meta-inclusive. And what I mean by this is that user experience should require buy-in from many parts of a business, developers, product managers, support teams, strategists, etc. User experience design really affects all of these different business functions. So they should each have their own input, and it should be designed by consulting all of these different teams. All right, so finally, with our design priorities in mind, let's take a look at some user experience. So this website here, Hyperdia, this is a trip planning website. As you can see, you can put in your location right here, and then you put in your destination, and then you can search. So one issue with this is that, if you don't know where you are in an unfamiliar place, you may have to ask somebody, hey, where's the nearest station? But if we compare this to maps here, Google Maps is taking advantage of an API that provides our location to the map. So as you can see, there's this dot here in the center of the screen, and that's where we are. So when we want to go somewhere, we just enter a destination and bam, it's done. This is a great example of abstraction of complexity. And there's obviously a lot going on here. Besides that, there's the visual context and adjacent information that users might want. And it's probably unrealistic for us to expect smaller competitors to build out the multi-billion-dollar mapping service and get all of this information. But in this case, we're really not, we're not even talking about that. We're just talking about the steps to achieve a task. And so taking advantage of the location API is a really great example of that. And it does a good job at abstraction of complexity. Another thing to consider too is that when we're on mobile, maps will abstract away unsafe activities like browsing restaurants when you're driving or biking. So, all right, next. I want to talk about fintech a little bit. And, Rakuten here, they've made it really easy to use a lot of these traditional services online, like a stock exchange, payments, digitizing cash, banking. And they've allowed us to use one ID to log into all of these different services, which is a pretty good innovation for abstraction of complexity. And then recently came a competitor called TransferWise, and they pushed this even further. They looked at this industry and said, well, fundamentally, all that's happening here is managing and moving money. So why don't we just build one experience around this idea? And the result is this very simple app that can do basically everything these other companies can do. So they reconsidered based on the context and technology of today. And they're even going to include investment tools in the next few months. So it will really be able to replicate all of the functionality of these different companies. So again, it's another step forward for abstraction of complexity. Similar with SoftBank. So SoftBank has lots of sub-brands and sub-businesses, all offering adjacent or directly competing services, Y-Mobile, SoftBank, Line Mobile, for example, and other brands. And actually with fintech, they're making, I think, a lot of progress in consolidating some of these brands with PayPay, as you see here. But then there's this American fintech app called Robinhood, which is here on the right side. And you can see that they've put all of these services, almost all of them, into just one simple interface. So all unnecessary complexity is completely abstracted away, and it feels like a complete experience. And so I think that's a really great example of abstraction. And I also want to call out Mercari, which was started in Japan. And they have a really interesting user interface here. So with one app, you can access a flea market, and you can also use the app to pay bills at store terminals. So it's a really great idea. It allows you to share a login and share a cash balance. It's the abstraction of complexity and getting rid of all of these different steps and allowing you to use one thing to accomplish multiple types of tasks. It's not a perfect experience because you still need to change, for example, flea market earning money into MetaPay, for example, and that's kind of an artificial step. But I think overall this is a really great example of merging different services together very elegantly, and it feels natural, and you can accomplish more with fewer steps. Another example, JR East Points, ViewCard, Suica Mobile, all the same company. And until recently, they all had their own online portals, their own user information. You had to separately create user profiles, and you had different login credentials, and it was really confusing. And finally, last year, they merged all of these together. So it kind of went from like the user experience from hell to becoming actually like a pretty decent user experience. And this helps not just with the abstraction of complexity, but it makes the experience feel complete. And it sort of like, holds in the user experience. There's clarity about how to use points and where to get customer support, for example. So next is signups. How many of you have experienced this before? I mean, this is still common for a lot of websites to ask for information several times when you're signing up for service. It's really annoying for users, and it's also completely unnecessary, especially for logins. I'm going to show you a much better way of doing this. So this here is a site called Coolers, and it lets you pick color themes for different websites. It's a really cool app. My friend Nick introduced this to me. And as you can see here, if you want to sign up for this site, you only have to enter your information one time, email, password, full name. And then after you do that, you just get an email like this. Very simple. And you have this little confirmation code, which they've even branded with a color code, a part of their branding. So it's really simple. You only have to put in your information once. And these days, most people use a browser that will save passwords for them. So double entering passwords is really double meaningless. Again, great abstraction of complexity here, reducing the number of steps. It's more complete, and it's trustworthy. Before any information is provided to this company, we've already verified that we have a real email address. And finally, so I want to talk about being upfront with users about costs. So this point here touches every single philosophy that I brought up today. And it's about being user-oriented, it's about being complete, and abstraction of complexity. It kind of bothers me that a lot of companies in the last few years, since the consumption tax increased, have started displaying their prices Zeinuki, or tax exclusive. Props here to, I'm going to show you Rakuten's website. As you can see here, they've actually decided to continue using tax inclusive prices. So when you see this price, you know exactly what you have to pay. You don't have to go through the step of calculating in your head, how much is this actually going to cost me? This is a really great choice in support of users, and it makes it a better experience overall for users. In fact, Amazon Japan does the exact same thing. And, unfortunately, this is Amazon America. I'm not sure why they have decided that they don't want to include sales tax on their sites. It's unfortunate, but, probably because in the US, it's a bit more common to use tax exclusive pricing. Yeah, so We live here in this age where it's very easy for us to just calculate these things for users and be upfront about what things will cost. Here we have the Marriott app. They have figured out how to do this for their users. Vending machines, they figured out how to do this. Why can't Starbucks figure it out? Marketers know that users will follow through with a purchase despite being surprised by their bill. And, but that's not really a good reason to not make this process more simple. So tax exclusive pricing is just plain bad user experience design. It's overly complex. It puts more work on the user and it adds unintuitive steps to shopping. And it's better to just build a trusting relationship with users by being upfront with them and not obscuring things. So, all right, so there we have it. So just to summarize, we want to create user experiences that conform to one's instinctive way of accomplishing a task. We want to abstract away complexity and create complete experiences. And we want to build a relationship of trust and protect our users. And to do this, we need to constantly test our work with diverse users and get input and buy-in from across our companies and organizations to make a better user experience and a successful app. So yeah, that's my monologue and got a lot off my chest there. And feel free to check out my GitHub and my Instagram and my LinkedIn. You can get all of them with this QR code here. Thank you.
Okay, Seth, thank you very much for the interesting talk. I'm sure that everyone who is watching here on track A learned a lot. So well done. And that's going to conclude the first half of our day. We're going to take a short break and all of us kind of stretch and have a little bit of food and something to drink. And we're going to be coming back at 3:30 with Kevin Key. So Kevin is going to be talking about achieving a good Git commit with CLI. So please don't miss that. And we will be leaving up the schedule here for the remainder of the intermission so that you can go ahead and decide where you want to head to next. So thank you and see you back in just a few moments. Okay, welcome back to Big MiniConf, everyone. We hope you enjoyed the intermission and had a good amount of Saturday afternoon sunshine. So to kick off the second half of our talks today is going to be Kevin Key, and he's going to be talking to us about achieving a good Git commit with a CLI. So Kevin, are you all ready to go? Okay, great. Everyone, let's give it up for Kevin.
All right. Thanks for joining today. Like Heather said, my name's Kevin, and I will be talking to you about how to make a good Git commit. So, start us off. Who am I? Like I said, my name's Kevin Key, and I'm from Vancouver, Canada. I've been living in Tokyo for some time now, and I come from a background in sales and marketing. So that was actually my first job in Japan. And it led me into coding. In fact, at a previous job, the tech lead there suggested that I try out some JavaScript. I did. I loved it. Led me into coding. And that's what I do now. And pictured on the right here is one of my favorite places to get work done, which is with a donut and some coffee. So, who is this? Excuse me. Who's this presentation for? Well, this is for anyone who does, wants to, or has to use Git. The presentation is built on some knowledge. It assumes a basic understanding of Git fundamentals, so basically what Git is. It also assumes that there's some familiarity with Git actions. For example, add, commit, push, that sort of thing. And also a familiarity with the command line interface, regardless of whether or not you actually use that. Another thing, this presentation is not specific to any hosting service. You might use one of these, perhaps not. But mind you, I will be including some screenshots of GitHub, but really, no matter what service you use, as long as it's Git, you're okay. So to start us off, a relevant question. Why should we care if a commit is good? Well, let's take a look at the dangers of a bad commit. Have you ever been in a situation where a Git commit caused some issues? I'm sure we all have. There are some consequences. Ambiguity. Ambiguity is costly. If people have to go digging into your commit messages, it's not an efficient use of time. A poor commit message is poor communication. And if your communication is poor, then it really is not good performance in any professional situation. It's also confusing. You may know what you changed in a commit that you wrote, but if your message isn't written properly, then rest assured your colleagues probably won't know. And eventually, you're just going to forget what you did. Our memories aren't as good as we would like to think they are. A commit message can well, really help with that. Good commits, well, what do? They help us. There are a number of benefits. It makes debugging a bit easier, quite a lot easier actually. If you're looking for a bug related to a feature you added last week, well, if the code and the commit message line up, then half your work is already done. Provides a logical history. So a Git history, it's sort of like a journal. It will help you to recall a past frame of mind to solve a current issue. And it communicates for us. So why bother explaining your code when your commit message can do that for you? So with that being said, let's learn about the things that actually make a good commit. So here's specifically what we're covering. Structure and composition. So these are the conventions and best practices for commit message composition. We're looking at character limits. That's the per line limits and why they exist. The code under commit. This is how much and which code to include in a given commit. Wording. How to articulate a message. And finally, issue linking. That's referencing issues or tickets in your message. So start us off, the structure of a commit. Now what we see here is first off some auto-generated information followed by a commit message in 3 parts. Now the commit hash, author, and date, those were all created by Git itself. We don't have to worry about that. We're looking at this 3-part structure here. So I'll be going over that, and then I will show a complete example. All right, start us off. First part. So this is broken into 3 subsections, as you can see: type, scope, and summary. Type. This describes the sort of change that is introduced by your commit using specific verbs. For example, feat could be feature. Fix could be a bug fix. These are conventionally written completely in uppercase. Scope tells you where the change took place. So this changes project to project. It could be, for example, if you're doing a React app, then the scope could be a component, or if you're building an API, it could be an endpoint. It's something you'll have to work out with your project team. Now, I'll point out that type and scope are completely optional. Smaller projects might not use them, and you might not see them even in every large project. But the summary is absolutely needed. This is the most important part of a commit. This is a short, concise statement summarizing the changes. It's not necessarily a sentence, and it does not end in a period. Onto the body. So this expands on the summary, giving full details of what changed. It uses complete sentences with punctuation. It can be as many lines as you want. It can be paragraphs. Bulleted lists are fair game. Those are very useful. And finally, the footer. And so this is a reference to an issue or a ticket number. And this is usually an issue found on your hosting service. Again, you're not going to use this all the time, and I will go into details as to what this means later, but for the time being, just be aware that it exists. So here's a full example. As we can see here, the commit tells us what we need to know right up front and center. We know it was a feature in the scope of calculator, and we added a class with constructor. So it's a pretty good summary. The body gives us more information. This is what we might need to know if we were to look into the Git commit in more details. And lastly, we know that this pertains to issue number 23. As I said earlier, don't worry about what the footer is yet. We'll go into detail, I promise. So now that we know the structure, let's look at character limits. So believe it or not, there are maximum length conventions for characters per line. In this example, here's something where it's just way too long. The message goes on to the second line. It's a bit difficult to read. So what is the maximum number of characters? It's 80. Here's basically the same information as the previous slide, but made to fit 80 characters. Why 80? So it's pretty much the same reason why we limit our code to 80 characters. It's because back in the 60s, the early I/O terminals could only handle this much. But here we see that we've got our summary, body, all comfortably fitting. The summary and body, actually, they have different sublimits. So this is where it gets a bit curious. The summary is limited to 50 typed characters. So let's break that down. Why? Well, you need 7 characters for the commit hash. And then you need 2 characters for the spaces, plus a 21 character sort of buffer for the remote and branch. Gives you 50 remaining to work with. For the body, you get a bit more room. It's 72 characters. You'll still need 7 for the commit hash plus 1 for the space. And you're not always going to see the commit hash when you're looking at the body, say in your terminal. But you do need to be aware that that is reserved space. So this might seem a bit strict, and it is, but it really does help with precision. And speaking of which, be precise. So let's look at this summary here. And it just says, made changes to calculator class. So this is not very informative. The only piece of real information we have is the word calculator. We don't know what do the changes pertain to. Is it more properties added? Is it a new method? Well, this is a bit better. So this uses an identifier, which we saw earlier, calculator. It concisely says what was done. What was done? Add. We added The round up and round down methods, great. That's a very informative summary. The body, good description, tells us what the methods do. And if you look at the end there, it also explains why these methods might return not a number. So that is being precise. But the precision doesn't stop here. We also have to be precise about what we include in the commit. And what do we include? Just one thing. So commit one thing. What do I mean by that? Well, let's look at this. This is a commit that if you read it, it's actually two things. Right? It adds validation for input, and it also fixes or changes styling to the front-end form. Now, these two things don't really have anything to do with each other. They really belong in their own commits. So this is better. These two unrelated changes have been split up into two. Now, why is this important? I mean, they both have the same scope. They both pertain to the scope calculator. But let's say that there was a bug found with the input validation. That's the first one, the one on the top. Well, as long as I'm fixing that bug, I'm preventing the styling changes from being merged into the master or development branch. So that's why I want to split them up, because I don't want to prevent the styling changes from making it into a higher level branch. So a good thing to keep in mind is the single responsibility principle. And this just states that a class should have one and only one reason to change. Now, this actually pertains more to software development than Git, but I think that it applies very nicely. So let's say that we're committing some changes and it isn't quite complete. We're committing something that we're still working on. Well, how do we handle that? WIP. So this is a convention abbreviation that we use for works in process. Let's look at here. This is a message that does not use WIP, but taken by itself, it is fair enough. A calculator, what are we doing? Trying to add validation for input. That's okay, but we can be even more clear about this using WIP. Here we have prefixed the first line with WIP. What are we doing? Calculator validation for input. So this is just a more clear way of communicating, and it's a very common convention. A lot of people use this. It's just a way where people will immediately know that you're working on something and it's incomplete, and so they won't bother you when it's not complete. Okay. And on to the last part, promise, the last one, citing issues in the footer. And this is the thing I was getting to it earlier, the footer citations. So here you see this. It says closes number 23. What does that mean? Well, in the footer, we use specific verbs to refer to issues or tickets, most likely issues or tickets that are present on our Git hosting service. And we use those specific verbs to say what we are doing in relation to that ticket. And the most common ones are resolve, close, and fix, and grammatical variations of that. So what's the significance of this? Why are we doing that? Okay, let's say we have an issue on GitHub, which is number 23, which is for looks like a bug fix. Bug calculator returning float. Okay. When I push to GitHub, this commit, which has in the footer closes number 23, GitHub is smart enough to recognize the verb closes and the issue number. What will it do? It will actually close the issue for me. And not only that, it will reference the commit hash, so the hash of the commit that closed the issue. Now, this behavior will differ across your hosting service. So I know from experience that a similar thing will work with GitLab. I haven't tried Bitbucket, Jira, just to name some others, but you can investigate those yourself. Yeah, very handy feature. So, to summarize, oops, structure as summary, body, footer. Keep to the 50, 72 character limits. Be precise. Commit just one thing. Use WIP for works in process. And cite issues in the footer. Okay, great. Now, let's demo. Make a real commit. Okay. So here, I have got some changes. Let's use git diff to see what I have changed exactly. So it looks like I've changed two files. The first is style.css, and it looks like I just added some padding there. Second one is in calculator, and looks like I've added some methods. So same in the examples we went over earlier. So naturally, I don't want to include these things in the same commit. I mean, they are, as we said earlier, they are unrelated changes. We don't want them together. So let's start off with the style, shall we? So let's see, where is that change? Where does it take place? Okay, here we are, CSS style.css. So let's git add CSS style.css. Hope we all seen the git add command before. Okay, let's just check. Yep, changes to be committed. There we go. All right, let me clear this. We are going to git commit with the M flag for message. And now we're going to write out the first line, the summary. So this project doesn't use a type, but it does use a scope. And I know that my team and I have agreed that even if it takes place in style.css, I'm going to use the class as a scope, so calculator. And what do? We see change padding on form. Okay, good. Summary. Body, and see, what should we put here for more details? Padding is 10 pixels. It's, I don't know if that was completely necessary to put a body here, but I've typed it. It's going in there anyway. Okay, good. And let's just check that. Git log. All right, there we go. Clear that. All right. We had some more changes, didn't we? Let's look at those. Git diff. All right, now what did we do here? We added some methods to the calculator class. So, oh, whoa, hold up a second. Is that how you spell calculator? Let's check that in a second. I don't think that's how you spell calculator. No, sir, that is not how you spell calculator. It's embarrassing. Let's change that. Calculator. How does that look? I'm going to assume that's correct spelling. Okay. Whew. Let's check that again. All right. So git diff. We corrected the name here, added some methods. Uh-oh. Now I've done it again. I've got unrelated changes, but they're in the same file. How am I going to handle this? Well, we have to add it anyway, but we do so with a P flag. And what does that do for us? Let me show you. The P flag is something really nifty. It lets us split changes within the same file into different hunks. Now, what's going on here? I'll give you some resources later so you can investigate this further. But just know that if prompted with this question, I can actually just write split, and it will, watch, actually split the changes in the file into smaller hunks. So do I stage this hunk? So the change in the class name? Yes, please. Change this one? No, it is unrelated. Okay, let's commit this. And what do I do? Scope, it's the calculator. Okay, good. What I do, I corrected the class name spelling. All right. I don't think I need a body for this. Okay. Lastly, I have some more changes. Okay, good. The name looks fine. We just have the those methods. Let's just add all. And now this is a bit more involved. So I want to be a little more verbose in this commit because these methods could have far-reaching consequences. So I'm going to add a V flag to commit. And let me show you what this does. This will let us actually write out the commit in a more, I guess, user-friendly way. So we can actually see the whole thing as we're writing it instead of sort of guessing outside of this, this Vim editor. So I'm going to go a bit faster because I'm arriving at the end of my allotted time here. So calculator, what did we do? We added round up, oops, round down methods. And let's use bullet points here. Round up, rounds input up, and round down rounds input down. All right. Let's save that. Git log. All right. We did it. We saved the commit. Okay. So before we wrap up, some useful commands. Git commit v, and that's committing in verbose mode. Git add p, add in patch mode. Those are the ones we used earlier. Look them up. They're very useful. And there are some others here we didn't really use, but they are also quite useful. Commit amend, if you want to edit the last commit, great for correcting embarrassing mistakes before you push them. That's about all I had for today. Thank you very much for listening to my presentation. If you'd like to connect, if you'd like me to explain a little bit more, I'd be very happy to. There's my GitHub and my LinkedIn. Feel free to get in touch in any way. Some sources on the right, that's where I do most of this material from. All right. Take care. And again, thanks very, very much.
Okay, Kevin, thank you so much. Awesome stuff. So up next, we actually have Shota Kaniguchi talking about no code, and that talk is going to start at 4 p.m. So please be sure to stay tuned and join us back at 4 o'clock. Okay, welcome back, everyone. So up next, as I promised before the break, we are going to be talking about no code with Shota Taniguchi. So Shota, are you there and ready to go?
Yes, I'm ready.
Okay, everyone, let's give it up for Shota.
Okay, hi, my name is Shota. Today I talk about no code. Have you heard about no code before? No code is a relatively new technology which is getting popular in Japan. No code, as the name suggests, is a new type of technology that allows us to build applications without writing a single line of code. So today I'm going to talk about how we can use these technologies and how should we face this brand new technology as an engineer. But before I go on to the topic of no code, please let me introduce myself. Hello, I'm Shota Taniguchi, and I'm now 25 years old, and I was born and raised in Kobe for about 20 years. And also my hobby includes playing shogi. For those unaware, shogi is a kind of like chess. Actually, I like strategy games in general, so they are pretty fun for me. Also, during university, I majored in Chinese and went to China for an exchange program in Dalian for about 1 year. So here is my memory of Dalian. Yeah, Dalian was really nice place. People were kind and the food tastes good and is surrounded by sea and mountains. It remained as my hometown, Kobe. And then this exchange program made me became interested in working in a global environment. So after graduating, I worked in the Chinese marketing department at the Japanese manufacturing company for about a year and a half. During my time at that job, I was running programming myself and found it to be super fun. As a result, I want to switch my career, and that's why I'm here in Code Criticize today. Okay, this is my introduction. Thank you for listening. So let's go back to my tech talk. The first topic is what is no code? So, as I said in the first introduction, no code is a software development platform that allows others to build and deploy their own applications without writing a single line of code. Now that we know what no code is, so let's talk about how apps were originally made before no code was introduced. So in traditional software development, programmers would write many lines of code by using programming languages like JavaScript, Python, Java, for instance, to create the functionality and behavior that was desired in an application. Writing code is often a complex and time-consuming task, which requires programmers to have an in-depth knowledge of multiple coding languages. Programmers would also need their own development environments, deployment processes, testing protocols, and so on. The introduction of no-code has made this process a lot more easier. So let's see how does no-code work next. So no-code platforms streamline the entire process and condense all those tasks behind the scenes. Instead, no-code platforms give users visual tools that they can easily operate to quickly build the application they want. So there's no need for user to write any of code. But actually, when building an application on the no-code platform, you are still technically building the code. The user simply don't have to write the code themselves. No-code platforms are essentially user interface builders, which remove the complexity of programming. You can use only drag and drop elements to quickly build your web page or application. In the next slide, I will introduce some no-code platform. In fact, a lot of no-code platforms has been released these days, and each of these platforms have their own unique characteristic. For instance, platforms like Bubble and Webflow allow us to create web application without doing any of the coding. It also surprisingly let us create applications with responsive design. The application will adjust to a laptop, smartphone, or tablet screen. Also, others include Airtable and Kinton, a no-code platform for cloud database services. And lastly, Shopify is a digital commerce platform where you can open a full-scale online shop. This is popular with many users because it has low cost, low payment fees, and supports a wide range of features. So as you can see, there are many no-code platforms these days, and this means that the demand for no-code is gradually increasing. So next, let's talk about who benefits from no-code. The biggest advantage of no-code is that you can create one application without writing any code, right? So therefore, even with non-technical individuals, most of the work can be done pretty easily without asking an engineer to create an application. Of course, product developers and web developers will also be able to use these technologies to improve their work efficiency by spending less time on easy to implement features and focusing other tasks that are more critical to the business. Okay, let's check out my demo of no-code platform. Today, I'm going to show you a super basic to-do application by using Bubble. So let's move to my application. So this is my to-do application created by Bubble. So you can see 4 tasks which I already input. Clean my room, wash clothes, go to gym, go to shopping. And you can also see the due date in the middle side, and you can see done button in the right side. So I already input new tasks, learn about React, and I wanna finish by today. So set that today and create here. So you can input learn about React tasks at the very top of list. So this is very, very simple app, but how did I create this application? So let's go to the creating page of Bubble. So this is creating page. And what we have to do is just selecting each visual elements and drag and drop. So for instance, let's create new button here. What you have to do is just drag and drop, and you can easily edit the size of button, and you can easily change the position of button. And in here, you can change the button name like that. Yeah, it's very, very easy. And also, Bubble can use database. So how can I use database? Let's go to workflow. So there are 2 workflows now, which I already created. The first is create button. So when I click the create button, these two steps is running. So the first step, let's see. This method is to create the new database. Type means database name. I called it to do, and these three methods is column of database. And also I set the finish column is no as a default. And next, this is for done button, and go to step. I set finished status from no to yes. Yeah, this is all what I did. And go back to my application and refresh. And you can delete your tasks which are you done. So let's click done here. That's all. Super easy, right? Okay, this is my demo. So let's go back to my Tech Talk slides. So next, let's talk about the advantage of no code. I think no code has mainly 4 advantages. The first, more agile. As you saw in my demo, most development is done via a drag and drop interface built visually with pre-built modules. This means building apps is a lot faster. In addition, testing is generally automated, which further cuts down on development times. Second, reduce the cost. From the company size point of view, developers are expensive. No-code solution gives many companies a way to bypass that, taking away a lot of overhead that comes with requiring a skilled team of developers. You can build apps faster and cheaper. Given these merits, no-code development can be said to be a suitable development method for a minimum viable product design. Third, increased productivity. Since apps can be built at a much faster pace, IT staff aren't overloaded with requests from every other department, and there are fewer people waiting for work to be done. What used to take weeks or months can now be completed in hours. At last, easily changeable. The problem with traditional application development is that you can't really change the functionality or feature at once, especially if you are coding in a language that is foreign to you. But with no code, you can. If you need to change something, you simply implement new logic and can have your change ready in a matter of minutes. So based on the previous slides, you may easily think that no code allows even non-engineers to create application in a short amount of time, right? So some may think that can no code be a substitute for developers? Yeah, I think that's a good question. In fact, when I knew no code, I had this idea as well. However, after learning more about no code, I found that the answer is no, it can't. Now, of course, it is easy to see the appearing advantages that no-code development platform offers. However, it is important for us to understand the hidden disadvantages associated with their use. So next, I would like to talk about the challenges of no-code. Here, the first business requirements. business requirements cannot be achieved with no code alone. Earlier, I mentioned that there are various services available for no code now, but there are some things that tools can do and some that cannot. There are many complicated requirements that a company has to fulfill. Using no-code platforms alone can't achieve these complex requirements. Second, extensibility. Once an application is released, it's not over. It is necessary to update from time to time according to environment, even if business requirements can be achieved. So there is a possibility that they will not achieve in the future. So before working with no-code, we must consider whether it can be handled only by no-code technology, including future demand. And it is very, very hard to predict. Third, dependence. Being tied to a no-code platform is a pain from a business perspective. This is because we cannot integrate different no-code platforms as of right now, meaning that we need to change platform if needed. Changing from one no-code platform to another is a time-consuming process, which becomes a constraint if you need to finish a feature that the current no-code platform cannot achieve. Last, maintenance. Currently, it is very difficult to maintain a product built using no-code platform with the conventional method of like writing code. The code can be recorded in a repository like GitHub, for instance. These allow various people and management to review the code at any time. However, with no-code platforms, this isn't impossible. Only the layouts can be seen. Any changes or flags cannot be seen. This becomes hard to maintain as we don't know what the original layout looks like. So, how can developers use no-code? Currently, many engineers face a chronic problem of heavy workloads. This includes many relatively simple tasks, and as developers, we don't want our workflow to be disrupted by these easy tasks, and instead concentrate on the bigger problem as much as possible. Therefore, you can think of using no-code and doing things that can be automated. For example, creating a single page like landing page or home page. It seems that there are many cases where engineers handled these in the past, but now that even non-engineers can easily create them. The sales side can complete this work. Second, creating a rapid prototype and usability testing. This technology is perfect for creating applications for rapid prototype and usability testing. It will make it possible to achieve user recognition faster and at a lower cost. Third, automated simple tasks. This may not be limited to developers, but it can be automated tasks such as data entry. This will save you a lot of time and give you more time to focus on your main business requirements. In the next slides, I'll introduce the technology future of no-code. So, Chris Wanstrass, who is the CEO of GitHub, left this comment. The future of coding is no coding at all. Yeah, of course, The chance of it replacing the developers in the near future is slim, since no-code in industry isn't fully developed, and complex products will always need the inputs of the programmer. But no-code is a great approach to product development that will enable non-technical idea owners to create their products, and it will have more influence for engineers. Also, I expected that Amazon's Honeycode and Google's AppSheet will attract more attention in the future. Even top tech firms like Google, Amazon, Facebook, and Apple has entered the no-code industry, so I'm expecting that no-code will become more popular in 2021. So lastly, let me explain my conclusion. My conclusion is no-code is the supporting technology of programming. At this moment, no-code is super efficient and effective to solve simple problems, but it cannot be a replacement of engineers at this moment. If you want to develop an application at this time, it is advisable to write real code. However, developers follow each other at a rapid pace, and it may be possible in the future to develop sustainable solutions by means of no code. So I think we developers have to keep an eye on the development no code. This is my take talk. Thank you. Thank you for listening. If you have any questions, please feel free to contact me. Here is my GitHub account. Thank you for listening again.
Okay, Shota, thank you so much for that interesting talk and very nice work indeed. So give it up for Shota one more time. So up next at 4:30, we are going to be meeting with Jack Fowler, and he is going to be asking us the question, is it time to break up with your monolith? So if you want to find out the answer to that question, please join us on track A once again at 4:30. And over on track B, we are going to be wrapping things up in just a little while with Nahoko Toyota, and she's going to be talking about everyday automation using Google Apps Script. So really thank you everyone who's been hanging out with us all day so far. See you again at 4:30. Okay, everyone, welcome back to Big MiniConf Track A. Up next, we have Jack Fowler, and he is going to be asking us the question, is it time to break up with your monolith? Jack, are you there? Are you ready to go?
Hello, can you hear me okay?
We can.
Should I share my video?
Yes, please.
Okay, hey,
Hey,
konnichiwa.
looking good. I'll turn it over to you then. Have a good one, Jack.
Thank you. Oops. Good afternoon, everyone. My name is Jack, and I will be talking to you about the difference between microservices and monoliths, two popular software architectures that we see today. So let's start it off. So presentation is breaking up with the monolith. How can you migrate over to microservices? So just a little bit about me. My name is Jack, and I am a full stack developer in Tokyo. And I was originally born in Columbus, Ohio, in the Midwest, or Chuseibu, as they say in Japan. And I've also lived in Kyoto, Awajishima, and Tokyo. So a little bit in the Kansai region and now Tokyo. And a little more of me, I do enjoy cats and dogs. I like the best of both worlds. And I also enjoy taiko and golf, wadaiko. So let's start it out. Let's get into what monoliths and microservices really are. Okay. So what comes to mind when you think of a monolith? Perhaps a large structure, an immovable object, something so big that you just can't move it, or maybe, yeah, basically a heavy immovable object that is very not very modular and not very flexible. It's kind of what I think when I think of monolith, just an old, large rock. So this is a little diagram of how we might represent an application. So we have all of our different modules or all the different components in our app all wrapped in one application. So we have maybe our green is our billing section, our orange is authentication, maybe the purple is one service, so the blue could also be another service we have. But everything is tied together and they all rely on each other. So let's say the orange section goes out, then probably the whole app will go down. And then if we want to multiply this app or distribute it, we need to create a whole new copy. So you can see this is a very labor and energy intensive. Now let's take a look at these, and we're going to break this app up a little bit. So we have a few little apps, they're all broken up into their own individual component or individual service. So and I have three little apps right here. I'm going to add another one. So we're going to add a new service. And let's say the service is doing well, or we're getting more demand. This is maybe a, let's use Netflix. Maybe we're getting more demand for our streaming. So we need to multiply our streaming service. So just keep multiplying it. But as you can see, compared to the last slide, we had to multiply our whole app. We had to create a whole new copy. But in this case, okay, the streaming service is the only one that is getting higher demand. So we can just multiply that. So we can just scale up the sections that need to be scaled. And you can see maybe there's another service, maybe it's billing. So, or maybe it's our Japan movie section, and we can scale that up as need be. And let's say maybe a section goes down. Well, we can just spin up another one just like that. Our system is designed for failure. So it's okay if we have an outage. So let's talk a little bit about what the need for microservices. Not everyone needs microservices, but some people definitely felt the, the growing pains of a monolith and issues with maintaining monoliths. So there's a need for breaking down the application into separate components. So obviously, with an application like Netflix or maybe at Amazon, we need to be able to serve our customers globally and at scale and on demand without any outages. So yes, of course, we want to be immune to failure and outages and also plan for this to happen. So this is where microservices can come in handy. And of course, with providing this service, we want to be on demand and instantaneous, regardless of the situation. So it's just a little diagram of what a microservice architecture might look like. We have an API gateway, which is sort of like managing our HTTP or network communications. And these are controlling, as you can see, these little boxes can be considered separate apps. And traditionally, one application has one type of database, but for each little node, we have a different type of data. So we have a MySQL database or even a Postgres. And also on the left and right, you can see some other services like Docker and Kubernetes that we're going to talk about just soon here, right after this. So what are the technologies that allow us to even use microservices or even use them cheaply and easily? Or what is the software that enables us? So with the rise of cloud computing, we have cheap on-demand cloud computing. So no longer do we need to maintain our own servers and have people maintaining those on the weekends. We can just leave this to Google or Amazon or other cloud companies and keep our applications in the cloud. And in order to maintain these applications or to create microservices, we need containers, which is you could think of as like a small virtual machine, the bare minimum requirements of an operating system to run an application. And orchestration software, think of like a conductor and orchestra, making sure that everyone is playing their songs correctly. Because now we have all these little microservices, and we want to make sure that they're communicating and working the way they should be. So we need orchestration software to monitor and maintain this software architecture. So we have Amazon EC2, which is our like little computers in the cloud. So you can think of them as just a computer, maybe without a screen, that you can access remotely. And we also have Docker, which think of as even smaller computers within these computers that can have their own little operating system. It's usually like little Linux operating systems, and they're in their own little package. And then to orchestrate or maintain all of these computers, all of these apps, we use Kubernetes, which as our orchestration software. There are other options. Also, Docker has like a Docker Swarm or Redshift. So these are not the only services out there. It's an example of a typical architecture. So you can have the Kubernetes as the brain of the operation. I don't know why I think of like the octopus, like kind of controlling everything. So we're going to go in a little more detail in this slide. So as you can see, maybe on the top left, I have the hardware. So you have hardware on the bottom. Obviously, you need a hardware to run a computer. So at each stage of the application, you're going to run your application on some type of system. So traditionally, on the left, we have maybe everything running on one computer, and it's just one app. And then we move to having more applications on one computer. You can see they're broken up in the virtualized development. And next we have Docker, which are even smaller, more compartmentalized applications running on top of hardware. And then you can see the Kubernetes software controlling all these little containers in the network on the right. And they're each in their own box. And these could be all running on the same hardware, or they could also be running on separate EC2 instances or separate computers. So let's talk a little about monoliths. This is obviously when we're doing app development, we don't always just say, oh yeah, we're just going to build a monolith. It's sort of let's just say a full stack application that is very matured and has grown, not out of control, but it's very mature full stack application with one backend language. So let's talk about it's a typical monolithic architecture. So the monolithic architecture is coupled and interdependent. So each aspect of the application relies on each other. So if one of your scripts is gone, then it might affect the whole application. So if you're going to make a change, you have to make sure that it's the right change because it could break your whole application. So with that, since we only have one application and maybe one API, we're only going to have one CI/CD pipeline. So what does this mean? So when we make a change to our application, usually our application sits in the cloud, we have to create a whole new instance of application. We have to reboot the whole thing. So this can obviously take some more time, but it's a simpler process since we only have one pipeline. And traditionally, of course, with one of these applications, we only use one backend language. Maybe it's Java or Python or Ruby. And generally, the team structure is broken up not by service or by the product or what objective they're focused on. Maybe broken up by skills. We'll talk about that soon. So here's just like a typical application. We have a UI, and that's making API calls to our server, and it's getting information. You can see in these network calls. And then let's say we have a front-end team managing the desktop UI. Then we have a DevOps team, which is managing the CI/CD pipeline, making sure that all the changes are good and the app is being monitored and maintained. And we have the backend team that is taking care of the database and maybe the middleware. So yeah, this is sort of a typical team is organized, very layered horizontally and not based upon like a product. Like they aren't the billing team. They're just handling the whole front end. So you can see there could be some lag. Let's say 1 week there's more backend work and the front end team is just sort of hanging out. So what are some issues with large scale monoliths? One is database and server outages. So if you only have one database, one server, and that goes out, that's really gonna compromise your application business, your trust. So any disaster that happens is going to be a catastrophic disaster. There's also issues with training new developers. So what do I mean by this? So let's say you have a giant application, everything is interdependent on each other. So before the developer even is able to make effective changes in the organization, it's going to take some time. So they're going to have to really understand the application inside and out, and it's going to be a headache. So there's a lot of mental load to just be able to make maybe one line of code change. So definitely just harder to onboard new people that are not experienced with this application. And of course, maybe slower deployment. You need to be very careful that you're not going to break your app when you make one change. So any change is going to be a serious concern. And we also have issues maybe with versioning in our application. So let's say we want to have maybe a new version of Java, but if we do a new version of Java, it breaks different parts of our application. So any small change is definitely going to be a huge consideration. So your application probably just want to run on one version of your language, so everything has to be updated at once, basically. So you can see how this is definitely going to slow down development and make teams less agile, and maybe they're not going to be ready for a change in the market or a change in their business if they want to adapt. Yeah, so adoption of new tech. Let's say they want to try the new shiny new language. Let's say it's like an Elixir or a Go or something like this, and they're using Java or Ruby, and they want to make part of their application or maybe the whole app in Go or one of these languages. It's going to be a huge consideration if they want to migrate over to one of these newer technologies. But moving over to microservices does not have to be a very dramatic process. You can approach it in like a step-by-step manner. You can slowly peel away your monolith, slowly chip away at the edges and break it down into more comprehensible, easier to understand components, more digestible components, you could say. So let's just dive into these microservices a little bit more. So microservices, obviously, since the application is in its own little container, so you need a way to have different microservices interact with each other. So we're going to use APIs and HTTP connections, networks to interact with each other. So there's definitely going to be more network going on. So this could slow down things, but gives you a little bit more flexibility and independently deployable modules. So what I mean by this, so if I have like a billing section or a movie section, then we can deploy those apps separately. So we're gonna have different CI/CD pipelines for every application. And we can obviously use multiple languages for each service. So maybe I have Golang handling this part, and I'm using this special database. But for another service, I'm using a completely different language. And the way that you glue these together is through network connections and these orchestration softwares that I was talking about earlier. So this is a little bit, just a little GIF. It's a little bit hard to see, but if you can see these little white dots, this is kind of picturing HTTP connections going across the internet. And each one of these little black nodes is a maybe a little app or a microservice. They could have a database, they might not, but it's just showing data flowing over the network. So we're going to take a look, and this is actually from a Netflix diagram showing Netflix microservice, like array of services. So this is just a small example. So we're going to drill into one little section. So this is a zoomed in view of one of these. So right now we're just going to say that it's just all going to one UI. But maybe for our users and billing section, we're going to choose Node.js and PostgreSQL. PostgreSQL is, it's very much supported by developers, and it's known to be pretty secure in terms of database. So we're going to want to put our billing information that is more, I don't say important, but a little bit more, it needs to be more secure. So we're going to choose Postgres. And of course, we're going to have some DevOps team and then 2 backend members and front end handling the billing team. So you can see this is a vertical team structure. When I was talking about monoliths, we're doing horizontals broken up. DevOps, backend, front end. No longer do we do this. We now have cross-functional teams, and they all handle every aspect of the development. They handle their CI/CD pipeline. So we can, this is another way to organize companies or organize services. And then on the right, we have our photos team. So maybe this is, I'm just saying this is the photos for, Netflix has a bunch of photos for like, the covers of a movie or, and maybe there's different photos for different regions. So maybe we use Amazon DynamoDB. It's, it's a document storage, a little bit faster serverless. That's why they choose Amazon DynamoDB. So you can see there's a little more flexibility, and you're going to have more options with the microservices. Another thing is maybe you could attract different developers if you have applications in your suite, and some use Java, some use Node. So if your company's only hiring Java, you could maybe attract people that are used to different technologies. So it's maybe it might be easier to recruit people as well. So what are some considerations if you're going to go with microservices? So microservices are obviously more complicated. They do give you more flexibility in terms of maybe you want to use a different version of Java for this service, and another service you want to use a previous version. So you want to use cutting edge, one you want to use a previous. So this is obviously going to have different nodes, and you have to manage the network connections, CI/CD pipeline, making sure that you're not like overloading your network in one section and you're not having bottlenecks. So it's definitely, to set up everything, it's going to maybe take more time and be expensive, but you may reap the benefits in the long run. And obviously, just because it's microservices doesn't mean that you need to go with them. You should find the right one for you. There's obviously drawbacks to every architecture. And because you rely on APIs and you have network connections, they're a little bit hard to think about conceptually, and definitely monitoring these microservices is going to be key. So you need to have a strong DevOps culture. And they're language and framework independent. So you can use different languages and different frameworks, different versions for each service. So you're going to have definitely a lot more flexibility, but you're also going to have to maintain different languages as well. So you might be spread a little bit more thin across your services, and you're going to have highly specialized engineers in each area. Or maybe with the monolith, you would have, let's say if the language is Ruby, everyone is very good at Ruby, so it's easier for them to work on different sections. They don't have to pick up the language. And there's less cohesion between teams. This is both good and bad. So if you have the billing team, they can just focus on their pipeline. They don't really have to worry about what the photos team is doing. And with the monolith architecture, sort of everyone is affecting each other. So you can kind of work in these silos of the microservices. So this is definitely beneficial. And again, the reliance on network and API connections. Now, you don't not want to make your microservices look like this, where it's so confusing that you've just broken them down to the most finest components. That's not the idea. You want to make them make sense. So microservices do not need to be like this. Let's say they can be whatever size they need to be, but just break up the application in a way that fits your business needs, or that makes sense for your product. Of course, all the services are not created equal. So I'll show you a few examples of different ways people do microservices. One example is maybe a company called the Guardian News section. They maintain a monolith, but for certain periods, or if they want to introduce a new service, they will attach a little microservice or spin up a microservice that is kind of expendable. So it's only there for a certain amount of time, and then they'll just throw it away once that period is over. So maybe it's drawing information from the main API in the monolith. And another, like the Netflix example, they're using a swarm of services, as you saw in that GIF with the black background and the white little connections going around. They're using a swarm of services. So maybe they have API gateways, they have like a billing database, and they have like a caching database. So it gets much more confusing, but maybe that is what fits them, since they have, different languages, different countries with different movie selections. So definitely they're gonna have different, different components for their needs. So just to wrap this up, obviously you just want to be yourself. There are a lot of different ways to do software architecture, but in the end, it's your decision, and you should not be, just follow all the trends, because that may actually set yourself back. One of the advice is to, of course, know your team, know your culture. In order to net microservices well, you need to have a strong DevOps and strong a backend team and good communication, because you have to be able to manage separate pipelines. And of course, in your market, do you actually need microservices? Is your company heading in a way that needs a distributed system? So if you think that you will need to do this, then it may be a good idea to invest in the microservice if you can see yourself scaling, because it is harder to go to microservices after monolith. It is possible, but it's just going to take more time if you don't build it as microservices from the ground up. But it's still always okay to start with a monolith. And of course, the long-term goal is you're going to have, if you need to get to market quickly, maybe the monolith will be better. But in the long term, if you do see yourself expanding, then it might be good to invest in microservices, hold out. So that actually concludes my presentation. Thank you for listening. I hope you learned a little bit more about modern software architecture. You can find me Onigiri Jack on LinkedIn, and I'm not LinkedIn, on GitHub and on Twitter. And if you want to learn a little bit more about microservices, I think one good resource is martinfowler.com, and also go to conferences on YouTube. Anyways, thank you for listening. Stay nimble, stay agile. Thank you. ありがとうございます。
Okay, Jack, thank you so much. That was really amazing. I'll, as always, appreciate the energy that you bring to your presentations and to the school. So thank you very much. So finally, concluding track A today, starting at 5 o'clock, is going to be Nick Taylor. And he is going to be presenting a talk to us about more information and less clutter using Popper.js and Intro.js. So really, really excited to see this. So yeah, we'll be back in about 5 minutes. See you for the final talk on track A in about 5 minutes. Okay, welcome back for our final talk on track A. So we're going to be wrapping up Big MiniConf today with Nick Taylor. And so Nick is going to be, as I mentioned before the break, talking to us about more information, less clutter using Popper.js and Intro.js. So Nick, are you there?
Indeed I am.
Okay, are you all ready to get started?
Yeah, let's do this.
Okay, I'm going to turn it over to you, Nick.
Okay, I hope everybody can see my screen.
We can see your screen, but we cannot see you. You might need to turn your camera on.
There we go. Now you should
There
see
we
me
are.
as well.
Nice. Yay.
There we go. Well, thank you so much, Heather. Thank you, everybody, for all the presentations today. It's kind of a little bit nerve-wracking going last after all those great presentations. But I just want to thank everybody for sticking around till the end and spending some time with me. I really appreciate it. I'm pretty excited to talk to everybody about more info, less clutter with Popper and Intro.js. But before we hop into that, I'll just do a quick introduction. So my name is Nick Taylor. I'm originally from California. So I grew up around Silicon Valley, and my father was also really into tech. So we would be going to computer shows every weekend and spending time, building up hardware and buying the latest games. It was a pretty awesome time, kind of that late 90s in Silicon Valley. I've been in Japan in the English teaching industry for the past 10 years, and I'm currently in transition to becoming an engineer and full stack developer. In the States, I was focused more on sales, specifically apparel sales, so clothing. Also, in my time in English teaching, I was working as a manager at one of the eikaiwas as well. So that's a little bit about me. As you can see, that's also the newest addition to my family in the picture. It's pretty great. But let's get straight into it. So I'm going to start with a question. What keeps you on a website? Now, this is kind of a difficult question because depending on what you're looking for, there can be a whole myriad of things that you want to see and what keeps you there. So the better question might be kind of what turns you away from a website. So we've all seen things like this and this, where it's just kind of data overload, that kind of old adage of too much of a good thing. They try to put everything into as small a space as possible. And then you kind of don't know where to look. You don't know where the focal point is. You don't know what you even want to find anymore. It becomes pretty daunting. And actually, some research has shown that most clients, when they visit a website, leave within the first 10 seconds. So that's pretty quick. And if you imagine when you're searching through Google or DuckDuckGo or whatever you use this week, how many times do you just go down that list without really reading much on the websites that you click on? You just kind of go there, immediately get that kind of, oh, not for me, and you bounce back out and look at the next link down. Now, if you look at the graph to the right, you'll also see that around 30 seconds, there's a huge drop-off in terms of users leaving. So the idea there is if you can keep them interested for about 30 seconds, then the chance of them staying longer and potentially coming back increases. So that's the big thing we want to take away, is that first 10 seconds is important, and the first 30 seconds is for longevity. So what does that mean? Well, it means you need to convey your value proposition in the first 10 seconds if you really want to impress and keep people coming back. Now, of course, easier said than done. So let's look at some things for retention, kind of keeping the eyes on the page. Now, the first thing we need to remember is it's impossible to please all the people all the time. Like we looked at those two examples earlier, where it's just data overload and it's too much. That's the idea. They're trying to get as much in there for as many different groups and demographics as possible so they can try to, cast a wide net. And that doesn't seem to work that well. It's just too much. Now, research also shows, specifically in Japan, for example, that there is a lot more of a focus on detailed information and, for example, reviews. So people do read a lot of reviews. So those things, while they're very data heavy and might be a little daunting, they have their place. But my argument would be that their place would be kind of after you get the person hooked. You bring them in with the simplest way, and then you give them the alternative of finding that deeper well of knowledge, whether it be reviews, deeper specifics about a product, those kinds of things. Now, there's a few things when you're looking at demographics, and most of my research was focused on age. It's the age demographics that kind of span all ages. It doesn't really matter what age group we were looking at, but these things are kind of always true. One is ease of use. Now, of course, that's probably true for just about anybody. Nobody wants to be challenged when you want to buy some shoes. You want that interaction to be pretty easy, and you want it to kind of follow your expectations, that you look at a product, you see the details you want. If you want to look deeper into the details, you look deeper, and then you just click a button and buy it. Now, the other one, which is very much connected to that, is concise information. Now, again, this goes back to those websites, keeping things to where you are conveying the smallest possible value proposition for your key demographic. Who are you trying to reach, and what is the minimum you need to reach those people? Of course, you can have all the other details in the back, and those are available. Again, we're talking about keeping eyes on the screen. So one thing you can use is Popper. What is Popper? Popper is a JavaScript library, and basically, it gives you a little pop-up. And these kind of things are very, very dynamic. You can use them to kind of show off a product or show off some other kind of feature, or just to give some instruction as well. But we can take a little bit of a deeper look in a demo right now. So let's just flip over here. So what we have here is a restaurant's website. So we've got their menu, we've got a little about us, we've got a nice little landing page. Very, very nice. And we have a color scheme, so we kind of want things to match as much as possible. Over here, we have our HTML. Now, I'm going to work completely out of this HTML document because flipping back and forth between files seems a little tedious at the moment. So what do we want to do first? Well, the first thing we need to do, of course, is make sure that we have the source for Popper. And you can see it right here. Of course, you can go to their documentation as well and pick up this link, or you could install it as an NPM package as well, if you so choose. The next thing we're going to do is just create that little tooltip. So what we're going to do is create a div. And this div is going to have an ID of tooltip. And that's purely just so we can reference it in our JavaScript. It's also going to have a class. And the class, we're going to call it favorite. Now, inside of this tooltip, we want to have a directional arrow. So if you just have a square, you don't really have any idea of the direction of it. Where is it pointing? Where is it trying to lead my focus? So we're going to put another div in here. And this one is going to have an ID of arrow and a class of arrow. And then we're going to put something a little bit interesting in here next, which is a little property called data Popper arrow. Now, if I save this, we should be seeing something right here. But as you see, nothing is showing up. So what we need to do is add some text. So let's see, most popular, try today. We add some text in there. Oh yeah, there we go. We got some text on the screen. That doesn't look great though. So the next step is making the actual JavaScript Popper. So I'm just going to go down to this open script tag I have down here, and we're just going to find these IDs that we placed. Also up here, we have an ID for this particular item called popular. So let's just get those into some variables. So we'll call popular, and we're just going to get it with a query selector. And There we go. But we're also going to need the tooltip. So we're going to catch the tooltip the same way with a query selector. And we remember the ID we gave it was tooltip. Very, very nice. Now, this is the fun part. We're going to use Popper, and we're going to use a method called create Popper. And this method takes in first our reference, then our tooltip, and then it's going to take in an object. In this object, we can put things in. For example, placement. So I want the tooltip to go to the top of the item I'm referencing. You can also use modifiers. Pretty fun. And with the modifiers, it takes in an array, and then takes in an array of objects. So this one, we're going to have a name of offset. We don't really want the tooltip to sit right on top of our reference point. So we're going to offset it a bit. So the options for the offset, and this also takes in an object. And for this, we can do offset, and it's going to be 0 and 8. Very nice. So here we have our Popper created. Now, if I save it, oh, well, the text went to the top, so that was expected. Still doesn't look that great, though. So I think we need to do some styling. Now, to save you guys a little bit of a headache, I've already placed some styling in here. So let's just uncomment this and talk a little bit about what the styling is doing. So I believe actually, yeah, class favorite, good. So if I save this, we should see, let me censor that out. And this needs to be displayed block. There we go. Now it's showing up. So what is this doing? Well, of course, with the tooltip, we gave it some classes and some kind of styling. So we got the color, of course. We got the text color, all the font weight, all the normal things you usually see. Now down here, we have the arrow. Now that arrow, we had to do a little bit of CSS magic with, because of course, naturally, it's going to be a square. So we don't want it to be a square. We want it to point at the object we're looking at. So we just rotate it. And then you can see we have a nice little tip that's pointing to the right place. Then we have these, which look kind of interesting. And this basically responds to the placement. So if I scroll, you'll notice that the popper jumps under the item because we want that popper to stay on screen as long as possible. We want people to see it. So it's kind of dynamic with scrolling, which is pretty cool. Very, very nice. So it looks pretty good. It matches the color scheme with the orange and white. But for example, what if we wanted to make the popper only pop up on like mouse hover, for example? Well, let's see if we can do that. So if we go down here, we still have this popper create popper, which is pretty nice. We might have to add some more functionality here, though. So if I, for example, make this, let's put this into a const, and we'll call it popper instance. Okay, that works. So what we're going to do next is make some functionality that will show it. We'll make a function show that will take in the tooltip. We're just going to set an attribute. The attribute we're going to set is data-show. And it's not really going to have anything attached to it. Then we're going to take that popper instance, type here, there we go, and we're going to set some options on it. Now what we're going to do is throw an object in here, and we're going to add some more modifiers. And these modifiers, just like before, we're going to take in an array of objects, and it's going to be name It's going to be event listeners. Very nice. And we're going to set enabled. So now that we have that, the bottom of Popper show, we can do Popper instance update. Update is just a method on Popper class. Very nice. Now, if we're going to show it, we also need a function that's going to hide it. So we can quickly make a function hide. And in here, we're going to, again, take the tooltip, and we're kind of going to reverse what we did in show. So we're going to remove the attribute, and the attribute we're going to remove is data show. Very nice. And then we're just going to take that Popper instance again and change its options. So this time, what are we going to do? Well, just like with the tooltip, we're going to just reverse what we did before. So modifiers, we're going to take in an array and object. The name is going to be the same. Listeners. And this time, enabled is going to be set to false. Great. This one we do not need to update. Now, this is an interesting part. We're going to set show events is going to be a new variable. And this is going to take in some of the kind of transitional qualities. So we're going to put in mouse enter. And when the mouse enters, what do we want it to do? We want it to focus. Now we're also going to have one for hide. In this case, I'm sure you guys already can imagine, mouse leave. And in this case, we're going to blur it. Very, very good. Now the final thing we need to do is do a show events for each. And we're going to throw in an event, a little arrow function in there, do popular add event listener event. Very nice. Then again, we're going to do another one with hide events. We're going to do another for each. We're also going to take in that event. And then we're just going to do popular dot add event listener event. Very, very good. Now, if I didn't miss anything, all we're going to have to do is this little piece that I forgot to comment out before, bring it back in, change that back to none, and our pop disappears and pops up when we hover. So as you can see, if you're really worried about having too many poppers, for example, kind of popping up everywhere, doing it that way is a much better way because then it only pops up when people are interacting with a certain product or with a certain asset on the screen. So very nice. So what we'll do now is head back to the slides. So thank you with the Popper stuff. We're going to take a look at what is kind of the benefits of Popper. It's very interactive and responsive. As you saw, it would move around the screen with the scroll. You can make it respond to different events. So it's pretty nice. Also, it adds context to resources. Maybe at the restaurant, we ordered too much of that particular beef. We need to get rid of it quickly. We can add that into the website, hopefully motivate some more customers to come in and get that for dinner, clear out our stock. Also, very interesting stylistically. It's very easy to style it and make it match whatever theme or style you have going with your website. And those are some reasons that I really like Popper. I think it's pretty interesting. So, continuing on, we're going to take a look at Intro.js, which was the other half of the title of this presentation. So Intro.js is very, very similar to Popper in that, much like their symbol shows here, it also uses tooltips. So you're going to see more kind of pop-ups coming up. Now this one's going to be a little bit speedier, so let's get straight into the demo. So now, if we imagine, let's go under here. We've got to use intro.js. So what we're going to do is just do intro Intro.js.set options. So you can even see some of the things are even kind of similar in terms of the names, set options. And that takes in an object, and it takes in a steps key. And what this does is it's an array of objects, and each object is going to be a step. So Intro.js is pretty interesting because it gives you the ability to use more of a traditional kind of wizard style demonstration of how to use a website. So for example, if we take in an element, let's say we want to bring in document.querySelector, and we want to bring in the menu intro. Okay. Then what we're going to do is take in intro. So the intro will be the message that we're using. So, let me see here. Expected that. Oh, I have to wrap this in an object. What am I doing? So let's just move these up in here. There we go. Now it should stop yelling at me. So the intro. Now, when we're looking at the menu, what do we want people to say? Or what do we want people to read? Well, we can just say, for example, see our menu. Let's just keep it simple for now. So very nice. So that's one step. Just for clarity, let's move that down so we can see that it's one independent step. Now what we can do is keep going here and add a .start. And that's as simple as it needs to be. If I save this now, the website's going to refresh. Maybe. Is it going to refresh? Oh, small little mistake here. I actually have to call intro.js. There we go. So now we can see our menu. It is highlighted with the rest of the website, has an overlay that kind of dims the background so your complete focus can be on what we want you to focus on. And just hit the little done button and it goes away. Now, you might be thinking, well, that could be very, very kind of annoying for people. Every time they visit your website, it just pops up automatically. And I agree. So what you can do, I'm not going to demonstrate it today, but one thing you can do is hook it up to a button. So for example, on the website, you can have a little help button. And when that is clicked, you can then trigger the start, which would be a little bit more intuitive for most people's use cases. But very nice. One thing we can do, though, for fun, is add in another step. So you can kind of see how the kind of wizard style of flow through the process works. So in this case, let's just do the, we do contact. Hopefully that shows up. The intro, contact us anytime. So when we refresh the page, it comes up and you can see there's a next now on there. So we go next. Yeah, I was worried about that. It doesn't seem to work very good in the nav bars. But yeah, it would go on to the next step if that next step is functioning. You can also just click out of it and the dimming kind of overlay will go away as well. So let's go on back to the slides and wrap up a little bit. So intro.js, what's kind of the good things about it? Well, one thing is it also uses tooltips. And as we've seen, tooltips are kind of all over the internet. Popper uses them. You'll notice them in things like Bootstrap as well. And you've probably seen them quite often in forms when you highlight over an input. It might give you a little bit more context of what they want inside that input. It also explains processes and actions. So if your website is has more of a kind of learning curve for new users, there's a little bit of a difficulty in starting, it's a very good way of doing a little hand holding for the users to make sure that they're on the right track and kind of get the full experience. Also, it's a very easy to follow structure. You can see that even compared to Popper, intro.js is extraordinarily easy. One thing, it's a little bit more difficult to style. So that's one thing to keep in mind. It's kind of a trade-off there. But that's all important. But what's most important, though, is the caution. Now, as you saw when we refreshed, intro.js can be very obtrusive, and forcing people into these little tutorials and these little kind of wizards, while they might be good for just giving them information, they also can really take you out of the experience of the website. So my key piece of advice is use it sparingly, use it when you need it, and like I said before, hook it up to a button, make it something that's an option for the user and not necessarily something they must interact with. So to wrap up, both of these JavaScript libraries, whether it be Popper.js or Intro.js, do a lot in terms of emphasis for value proposition. So like I said, you could add these little contextual additions to the resources on your website to give people a little bit more detail without overwhelming them with too much information. Also, they're very responsive and interactive. They follow the screen. They have kind of click through like a wizard. There's a little bit more interactivity with the user, which is pretty fun. And finally, they add style and interest. As you can see, Popper.js and Intro.js are not that challenging in terms of setup, but they add a lot of production value. And they can be a lot in terms of showing your professionalism on the website because they are very, very well formed out of the box. And they add that value. So moving on, I'd just like to say thank you to everybody. It was a long day with all the presentations. And again, thank you so much for sticking around to spend this time with me. If you'd like to get in contact, anytime on LinkedIn, GitHub. And if you want to play around with Popper.js or Intro.js with the same kind of website that I was playing on it with, then please check out this QR code and you can download the GitHub repository that I have linked up already. So thank you so much, everybody. See ya.
Okay, Nick, thank you so much. What a fantastic way to end what might have been our biggest big MiniConf ever, actually. Certainly, it was a bunch of talks in one day. So I hope that everyone here in our community enjoyed that just as much as I did. And so what I want to ask everyone is to save the date, March 25th. So at the end of next month, starting Monday, I guess, we will be presenting these presentations from the senior projects, which the students are actually about to start on. So let's come in and see what the big difference is between today and week 12, and hope to see you all there. As always, thanks so much to all of our community members for their support and for, just kind of continuing to help our students through their journey. So thank you so much. Have a wonderful and safe weekend. Stay warm. See you at Demo Day. Goodbye, everyone.